Okay, YouTube, this is my fourth video in my module on factoring, which we're going to focus on a couple of special factoring patterns here, notably the perfect square trinomial as well as the sum or difference of two cubes. Okay, so let's start with perfect square trinomials. What I want to point out is essentially this. In my last set of videos, when we talked about polynomial multiplication, we talked about some special multiplication patterns. Essentially, what we said was if you were to take a binomial and square it, and it's a sum of two things. We just basically got the first thing squared in front and the second term squared in back, and we got two of a's times b's, okay, in the middle, all right? And likewise, if we had a difference binomial here and we squared it, a perfect square binomial, it was a difference, we got the same thing except for this sign here became negative. So we're working backwards, recall, in terms of what we're doing. We're trying to find a way to factor trinomials. And in this case, we can recognize this special pattern because I guess I'll point it out here. It says the first and last terms are squares of monomials or integers. So I noticed that x squared is a perfect square, and 49 is really notably a perfect square. If I said, well, what is x the perfect square of? Well, I squared x to get x squared. And what is 49 the perfect square of? 7. And I noticed that this middle term is 2 of 7 times that x, okay? So if that's the case, then what we could do is I could say, well, then really what this does is it factors into this perfect square binomial where we say I've got an x here and I've got a 7 here, and this must have been a sum because I've got a sum here. So one thing I do want to point out is this: if you are uncomfortable with that fact, x plus 7 squared, really, you guys, is x plus 7 times x plus 7. And I could have said, well, then let's factor this like a trinomial. If I were to factor this like a trinomial, I would have started by saying, well, what could I multiply in front to get my x squared? Well, it would have been x and x. And what can I multiply them back to get my 49? Well, it would have been maybe like 7 and 7. I'm guessing and checking. And I say, well, they both have to be positive because the middle term is positive here and this is positive here. Bottom line is you could just do it very quickly if you can recognize that this is a perfect square trinomial. Likewise over here, I mean, it really sticks out that this first term here is a perfect square and that the last term is a perfect square. So, maybe there's a chance that if I were to put these in and say, well, then that's a perfect square of 4x and this is a perfect square of 7, and I notice that this is a difference here, maybe I put it in a minus here, would this work? And according to our rule up here, we'd say, well, 4x times 4x is 16x squared, 7 times 7 is 49, and if I were to say 2 times 4x times negative 7 here, 2 times, the two terms we have here are a's and our b's, where those are the terms respectively. 2 times 4 is 8 times 7 is 56, and of course, I would have had the x in there as well, so 56x, and because one was positive, the other one was negative, we would have had a difference here, okay? So that being said, let's take a look at another special factoring pattern. We say a sum or a difference of cubes. Now, in a previous video, we said that you can factor a difference of two squares. It's a plus b, a minus b. But you can't factor a sum of two squares. You just can't do it. I mean, it's just not factorable. So what I want to point out is you can actually factor both a sum and a difference of cubes. And this factoring pattern is kind of a nifty little thing here, but I want you to see this first. We say that a cubed plus b cubed, if you wanted to factor this, you always get a binomial times a trinomial. This is always going to happen. So we get a binomial, trinomial. And I'll promise you something else too, because I said in the last video, you need to make sure that you factor completely. This trinomial right here, once you get it into this form, will never factor. I mean, it's like you're stuck after you factored it down to this point. So here's what I want to point out. In this first binomial, we have a and b, and all those numbers values are really just the cube root of a cubed and the cube root of b cubed, okay? So, I mean, whatever, you'll recognize some cubes down here, like x cubed is a cube, and 1 is a perfect cube of 1. So when I write this out as my binomial here, I'm basically going to say, well, the cube root of x cubed is x, and the cube root of 1 is 1. Or in other words, these are the things I can cube to get these two things. And the next thing I'll point out is, this basically denotes that you have the same signs here. So this is going to be a plus 1. As far as what you get in this trinomial over here, though, I'm going to point this out. The last term is always positive, okay? And then this first sign here is always the opposite of the first sign we started with right here. So this will be a negative, okay? And what the values of these terms are, you'll notice here I have a squared minus ab plus b squared. All I'm going to say is really to get a squared, all you have to do is take a times itself. To get ab, you take this first thing times the second thing in this first binomial, and to get b squared, you take b times itself. So essentially, here's what you're going to do. You say x times x in this case, x squared, x times 1 in the middle, x, and 1 times 1 on the outside. And that's all this really is, okay? Looking at this last one, I also recognize that this has two terms, and these are definitely cubes. So I'd say, well, maybe this is a difference of cubes. It obviously is a difference of cubes. And we'll start with our binomial before we crack into our trinomial here. But we say, well, 125x cubed. You know, what could I cube to get that? Well, I could cube 5 times x. You know, cube that, you get 125x cubed. And what can we cube to get 8? Well, it's 2. And knowing what I know up here, it says, well, these first two signs must be the same. If this is a difference, this is a difference. And if that's a difference, this next one's a positive. And the last one's just always a positive. And to get these three values here, we say, well, 5x times 5x is 25x squared. 5x times 2 is 10x. And then we say 2 times 2 is 4. And this is completely factored.